Okay, I wanted to pick up in the textbook where I left off in the slides. And this is going to repeat some of what we just did in the slides, but I think it's worth repeating. So remember that 2 to the 5th design. We had a quarter fractional design here, 2 to the 5 minus 2. And the generators for the design were A, B, C, and negative C, D, E, which gives this as our other defining relation. I'm going to skip down in the textbook to here. So there's a simple rule for determining which effects are going to be aliased. And we've already worked through this, I realize. But I wanted to show you this and then get to a bigger example just to show you how complicated it can become. Okay, so remember in the notes we took a look at this set. And you could see quite directly, this is a different example than we went over in the notes. This one uses C as the main effect rather than A. The one in the notes used A instead. But notice how this all comes about. But you could start with I, then A, B, C, D, E, and then finish your set of your complete set of aliases. This you have to do during, when you're figuring out which kind of fractional factorial design you're going to implement for your experiment. This is done prior to collecting any data, or else you may find yourself in a bad state of affairs if you don't think this through first. Okay, so here's what I wanted to get to. For more complicated designs, you just follow the same pattern. It's just a lot more work. And the defining relation for your fraction will include I, but all of the other generators and their interactions. So if you have a 2 to the 8 minus 4, so this is a huge design, and your set of generators is given here. I'm not going to read through all those. Then the defining relations are going to be all the following. So this is all of our generalized interactions that result from those generators, those defining contrasts, okay? You go through all the interactions, I'd like to point out. So there's 6 two-way interactions, 4 three-way interactions, and so forth. Let's finish reading. And then the four-way interaction. So every degree of freedom has 16 names, and every effect is aliased to 15 other effect. So this is really complicated, and take a look just so you can see. So if you have a design this big, I really recommend, number one, you consult some software because, there's really no reason to go through all of the work. You want to understand how this is generated, and hopefully this class will give you enough of a primer on that. But this becomes ridiculous, and bigger designs are possible, like we talked about 2 to the 10. What if you have a quarter fractional to the 10 design? You would spend a whole day trying to come up with your set of aliases. So it becomes too big. So there is a package in R that will do this for us, and I'm going to go over that a little bit in class. But I also wanted to show you in the text on, let's see, this is page 478. He also gives just a set of steps for constructing. I'll probably have you do this one time in the homework just for a small fractional factorial. I will not have you do this for a very large one because like I said, I just would recommend software in that case. He works through, this is partly where we also left off. We took a look at this in the notes. It was a different example, of course. This is a bigger design where you use a fractional design and your base design versus your final design. And so you realize if you're estimating, say, grand mean, you may actually be estimating the effect H. So you just need to be aware of that base design versus final design. Okay, so now we're going to get into the analyzing. Let me switch back to the notes. Let's talk about this in class a little bit. This idea of the resolution. There are resolution effects. I did bring up a table because I kind of hate that there's not a table like this in our book. Yeah, here we go. This is just off of Wikipedia. So you can define the resolution, and in general, until you get to level 3 for your resolution, you don't have a well-defined fractional factorial. So what is resolution? Resolution is just that ability that the design has in separating out your main effects from the more salient interactions. So in effect, your lower order interactions. In general, you don't want to go with resolution 1 or 2. And the reason is in 1 and 2, you're going to have main effects confounded with other main effects, most likely. And so you're going to have to give up effects in your model that are most likely things you need to know, that you need to understand. So in general, when we work with software, you want to begin with resolution level 3 or go beyond that. I don't think going beyond like 6 is ever reasonable, because then you start focusing and expending energy on eliminating high order interactions that are just not even worth the while, not worth your work. So I don't know. I feel like the sweet spot is in between 3 and 5, more likely. Let's see. Here's Gary's take on it. Let's see what Gary thinks. All right. Resolution 3 designs are not going to alias your main effects, so that's good, but they can alias main effects with two-factor interactions. Sometimes that's okay. Okay. These are sometimes called main effects designs because that does happen. If you have level 4 designs, they don't alias the main effect with 2 factors, but they do alias 2 factors with other 2 factors. So maybe 4 is going to be more important to investigate for designs where you know you want a fully to be able to fully identify all the main effects independent of the two-way interactions. Then resolution 5 level do not alias any main effects or two-factor interactions to each other, but these can become very complicated, the resolution 5 designs. Okay, generally you want the resolution to be higher, although I wouldn't go too high. I guess I disagree with Gary on that. It just becomes too complicated and I'm not sure the point anymore. Aberration is a term that just refers to the count of your number of aliases of I of different lengths. Okay, so this gives you the number of letters that the number of effects that you're aliasing. Design A has a smaller aberration than design B if A has a smaller number in the first digit where they differ. You want lower aberrations in your design. Okay, just a design principle there. So here's a 2 to the 7 minus 2 design. The aberration is indicated in the subscript here. Each design has a lower aberration than the ones above it. So notice the aberration here where our defining contrasts are this set. Our aberration is lower order in terms of it is 1 and 2 for level 4. And notice everything has a beginning for aberrating level 4, hence the name, or the subscript here of 4. This design where you use the 4 level interactions for your defining contrasts is got the highest order aberration. I would just choose between these two. I'm not sure. It would kind of depend upon what two-factor interactions you want to preserve about which one you would decide. You can read over the remainder of the notes on your own. In the interest of time, I'm going to skip over it and spend a little time in class showing how you can use the DOE package in R to generate these designs as well.
Okay, well, you can see this collage